Okay, cosine because it is adjacent over hypotenuse. Alright, next one. Tangent. The ratio. Okay, for tangent, which side over which side? Opposite. Over adjacent. Okay, now the next one. Yes? Okay, let's move on to the next page. Alright, now everybody, give me your full attention. Stop talking. This is the final concept that we have for our syllabus. Omara? Final concept already. Once we master this, we finish our syllabus. Now, from the top of a building, the worker observes a truck at a car park. Calculate the angle of depression. You need to know where the horizontal is. Where are we looking from? Are we looking from the top or from the bottom? You are looking from the top, right? In the question, they say the worker is at the top, looking down. Now, imagine you are the person at the top. Where is your horizontal? I need you to draw the horizontal. All these questions must draw horizontal. So this is the horizontal. Okay, draw this line. In your book, you have to draw it. Because that is how we determine. We use that to determine where the angle of depression is. From the horizontal. So obviously, this must be parallel to the ground. They are parallel. So where is the angle of depression? I've been doing this action from the horizontal down. This is the angle from here to here. Okay? So same thing. From the horizontal to wherever the truck is. This is the angle of depression. So please write that down first. Of depression. So how much is this angle of depression? Angle equals to, okay, what do you think this is? We are trying to find that particular angle. Yeah, that blue angle over there. Not difficult, don't think that it's trigonometry. It's not. 90 minus 47. Because there is a right angle over here. This portion is a right angle. Okay? So the angle of depression is simply 90 minus 47 degrees. And we get 43 degrees. That's all. That is the angle of depression. Okay, now for my own question, okay? In red, what is angle of elevation from, you don't have to copy this down, from bottom of truck to worker. Okay, so in this question that I came up with myself, I am asking what is the angle of elevation from the bottom of the truck. So pretend somebody is lying on the floor. Somebody is lying on the floor and he's looking, his eyes are over here. Okay, and he looks up at the worker. Where is the angle of elevation? 43, huh? Is it 43?
Yes.
So you must know where the angle is first, right? The angle is over here. This is the angle. So Andre says that it is 43. Do you all agree? Why would it be 43?
You can either do the Z1.
The Z1, what is that Z1 called? Alternate angles. Right? Alternate angles, parallel lines. So if this is 43, then this must also be 43 degrees. Because angle, your alternate angles parallel lines. So you notice that angle of elevation, the opposite, which is the angle of depression, if you are talking about the same two objects, it's going to be the same. It's going to have the same value. Okay? So, what are some real life applications of angles of elevation and angles of depression? Horizontal ground. Horizontal means flat. A and B, they are on horizontal ground. B is the foot of a vertical tree. Foot is just the base. Okay, this is the base. So it's like a tree over here. AC is 94, BC is 55. Angle of elevation. So elevation from of C from A. From A. Okay, English very important. Angle of elevation of C. We are trying to look at C. From where? From A. Can you draw an eyeball? Can you draw an eyeball? Where's the eyeball? So you just draw an eyeball like this, just like this. Just to know where we are looking from. And where's the horizontal? Remember we said always the horizontal, then we check the angle. So this is our horizontal. And he is looking up to C. C is over here. So you look up and this has to be the angle. This is the angle that we want. This is known as the angle of elevation. From horizontal, look up, find this angle. Okay? Are you able to do it? How? Which one? Okay, so Fauzi says that we have opposite. What else do we have? Hypotenuse. Opposite and hypotenuse. I've got opposite, I've got hypotenuse. What trigo ratio should I use? Which one? So, sine. Opposite over hypotenuse. Okay, sine. So, sine, we form our equation. Sine of an angle. Which angle? Okay, theta, but I don't want to introduce too many unknowns. So we have a name over here, right? BAC. This is the unknown. Angle BAC. So sine BAC. And this gives us the opposite over hypotenuse. We know the opposite is BC, which is 55. Over the hypotenuse, which is 94. And now we just need to find out this value. And we already have the skills to do it using our calculator. How do we get the value of angle BAC? What should we do with our calculator? If I sine of an angle equals to a value, how do I get back the angle? How do I reverse the operation? Which inverse ratio do we use? Sine inverse. Okay, so take out our calculators. Sine inverse. So press shift sine 55 over 94. And we get 35.8. 8105. So we round it off to 1 dp, 35.8 degrees. Why 1 dp? Because it is in degree. That's all. So this angle is 35.8 degrees. Is 35.8 degrees a big angle for angle of elevation? Can you imagine looking up 35.8 degrees? So about 45 degrees is about halfway. 35.8 is less. So I think it's quite manageable. Are you able to look at an angle of elevation of, let's say, 80 degrees? 80. You show me? Can you do 80 degrees? Okay, Hui Ling can. Just go all the way up. Okay, or even 90, go all the way out. Feel your neck also. Okay? 180 cannot already . Okay, question 3. So now B and C, there are 2 points on the horizontal ground. It's a flat ground. A balloon is at A, vertically above B, so there's a right angle. Angle of depression of C from A. Okay, I want you to identify where the 45 degrees is. Okay, do it yourself now first. B, okay, we want to find this value over here.
Oh.
We have another piece of information. This is 37 meters. 37 meters, I got an unknown distance. I got an angle, but the angle is not inside the triangle. Then how? Which angle do you want to find, Chen Si? Angle? A? Must be 3 letters. 3 letters. CAB. Okay, let us find this angle. Angle CAB is 90 minus 55. And we get 35 degrees. So this is 35 degrees. Then what do we do from here? Got 35 degrees, then so what? We need to involve these 2 lengths. So with reference to the 35 degrees, what is the side BC known as? What is it called? What is the name of this side BC? Opposite, with reference to 35 degrees. Okay, I've got an opposite. What do I require? What is this side called? Adjacent. So if I have adjacent, I have opposite, I have angle, which trigo ratio do we use? Which one do we use? Tangent. Okay, so tangent. Tangent what? What is the angle? 35 degrees. Tangent 35 degrees equals to the opposite. We know the opposite to be 37. Over adjacent. Adjacent is an unknown. So let's call it AB. That's what we want to find out. Okay, now from here, good. We draw one line at the bottom. Over 1. Draw your cross if you need to. Then continue to manipulate. AB times tangent 35. AB tangent 35 degrees equals 37 times 1. Times 1 no need to write, but you want to write also can. Now I only require AB. So I need to remove the tangent 35. I do so by dividing. Divide both sides by tangent 35. And we end up with AB only, which is 37 over tangent 35 degrees. At this point, use your calculator. Okay, so that's all we have. 3SF because we are dealing with the length. 1 dp for degree, that is angle.